Welcome back to Cyber Guy from Zero. Let's get started.
All right, let's just dive right in. Welcome to this explainer. Today, we are breaking down the complete anatomy of a cyber attack. We're not talking about some abstract theory here, folks. We are mapping out a real, documented, start-to-finish digital heist using one of the most infamous vulnerabilities in recent history. We'll see exactly how an attacker cases a target, picks the digital lock, and achieves a total system takeover. Here's our blueprint for today. We're going to start by looking at the digital training ground, then move on to scanning for open doors, deploying the EternalBlue exploit, planting our invisible inside man, and finally executing that total system takeover. Let's get to it. Part 1, the digital training ground. Because, every good heist needs a staging area. Now, I gotta point out that we are operating in a safe, simulated lab environment. We're using a NAT network inside VirtualBox. Basically, this lets our virtual machines talk to each other and access the internet, but it builds a solid brick wall between the lab and your actual home network, or safely behind the glass. So meet the two main characters in our little drama. On one side, we've got the fully equipped attacker machine. This is running Kali Linux, stacked with 6 gigs of RAM, sitting at IP address 10.0.2.15. And on the other side, our target. It's a legacy Windows 7 machine, just 3 gigs of RAM over at IP 10.0.2.3. The stage is set. First things first, we need to make sure they can actually talk to each other. A quick ping command from the attacker to the target's IP confirms we have a clear line of sight. The replies are coming back in milliseconds, 0 packet loss. The heist is officially a go. Moving into part 2, scanning for open doors. Time to find our way in. You wouldn't rob a bank without checking the blueprints, right? So after verifying connectivity, the attacker fires up a tool called Nmap. Think of Nmap like someone walking around a house, quietly jiggling all the doors and windows just to see what's been left unlocked. And bingo, look at this scan report. Ports 139 and 445 are wide open. Now, in the Windows world, port 445 is absolutely crucial. It's used for SMB, that's server message block, which handles file and printer sharing. But on an unpatched Windows 7 machine, man, an open SMB port is literally like a giant neon sign for hackers. Part 3, the EternalBlue exploit. This is where we break the lock. Having found that open side door, things are going to get highly technical and incredibly fast. The attacker fires up Metasploit. If you're not familiar, Metasploit is basically the ultimate hacker's lockpicking toolkit. It's this massive framework packed with modules for scanning, exploits for the actual attack, and payloads, the code that runs once you're actually inside. Here, the attacker loads up the MS17-010 scanner and points it directly at the target computer's IP address. By setting the R hosts, which just stands for remote hosts, to 10.0.2.3, the attacker is explicitly telling Metasploit, hey, focus all your power fire right here. And boom, this is exactly what an attacker wants to see. Notice that green plus sign? Host is likely vulnerable to MS17-010. That is the ultimate green light. MS17-010, by the way, is the Microsoft security bulletin for the infamous EternalBlue vulnerability. We found a way in. So here's the exact sequence. The attacker switches from the scanner to the actual exploit module. They set their target IP, they set their own local IP so the target knows exactly where to connect back to, and they hit run. Just like that, the EternalBlue exploit is sent flying across the network. Our custom lockpick is in the door. Which brings us to part 4, the invisible inside man. Time to establish control. So the exploit is fired, the door is open. Now we need eyes and ears on the inside. The payload we're using here is called Meterpreter. When the EternalBlue exploit hits, it injects the secret shell. It's essentially a silent, hidden remote control that gives the attacker total power without the actual owner of the computer ever batting an eye. This right here, this is the cinematic climax of the hack. Look at that single line at the bottom. Meterpreter session 1 opened. That means the target machine has actually reached back out to the attacker's machine. The bridge is up. They are officially in. Immediately, our invisible inside man starts quietly gathering intel. The attacker types sysinfo, and the target just eagerly spills all its secrets. Windows 7, 64-bit architecture, computer name Santosh-PC. The attacker is getting the total lay of the land. Then, by typing the simple command shell, the attacker drops right into the native Windows command prompt. Look at that classic C:\Windows System32 prompt. It is literally as if the attacker pulled up a chair and is physically sitting right at the target's keyboard. They're inside the machine's brain. All right, part 5, total system takeover, the final phase of the heist. Now, a temporary hack is annoying, for sure, but persistence, that's a full takeover. The attacker needs to make sure they can stay in control forever. To pull this off, they execute a really simple 3-step privilege escalation. Create a brand new user account, sneak that account into the local administrators group, and then double-check their work. Right here, they send the command to add a user named Santosh Adhikari to the local administrators group, and the system just happily replies, "The command completed successfully." It's that easy. In a fraction of a second, this rogue ghost account just grabbed the keys to the entire kingdom. And here is where it gets super creepy. Look at the graphical login screen on the target machine. The rogue account is sitting right there, plain as day, next to the original owner. The attacker doesn't just have some hidden command line access running in the background anymore. They have a fully interactive account right on the front door. The heist is totally complete. The attacker logs in using the password they just created right into the regular Windows desktop. From here, they can change settings, steal personal files, or use this newly conquered machine as a pivot point to attack other computers on the same network. It is an absolute, total compromise. So, I want to leave you with this thought. We just watched an attacker go from simply scanning an IP address to complete administrative GUI access in a matter of minutes. All of it purely by exploiting one unpatched vulnerability on port 445. If a legacy system can be compromised this easily in a lab, how secure are the older machines still running on your own network? It's a stark reminder that updating your systems and patching vulnerabilities like EternalBlue.
If you found this helpful, hit the like button and subscribe to Cyber Guy from Zero. I drop new videos every week on Try Hack Me, ethical hacking, and the road to becoming a cybersecurity professional. See you in the next one.